Managing tables and indexes. In this nugget, we begin a detailed consideration of the fundamental unit of storage in any relational database management system, or RDBMS, and that is the table. We'll start by discussing table properties and some of the design considerations that go into building your tables, and then, of course, as usual, we'll turn to the nuts and bolts in MySQL of creating tables, altering tables, and dropping tables. There's quite a few nifty tricks embedded in this nugget, so I hope you're as excited as I am to learn. Let's get to work. Let's consider some of the architectural properties behind MySQL tables. You'll notice in my first bullet point here I made an edit, and this just speaks to the reason why I left this edit in. Normally as a developer you have these kinds of things be invisible to you, the student. However, the reason why I left this edit in is to underlie or underscore an important point with MySQL specifically and open source products in general. Depending upon where you're going to look up your information, you may find conflicting, contradictory, or just plain different data. So I had an original maximum of 1024 columns in a single table, theoretical. However, that source, which escapes me now, perhaps it was one of the MySQL Press books, doesn't line up with what's online in the MySQL reference manual. Therefore, I've updated it, and you should know, if not for the exam, just for trivia reasons, so you can win with your nerd friends in a MySQL trivia contest. And by the way, I use the term nerd as lovingly as possible. I am certainly one of those. At any rate, according to the reference manual, a single table in MySQL can support up to a hard-coded upper limit of 4,096 columns. Now really, practically speaking, friends, 1024, 496, that's kind of crazy, isn't it? Especially if you believe what I told you earlier in this course when we discussed the 4 basic steps of database design, and in particular when we're looking to normalize our table structure. There you're actually reducing the number of columns to the bare minimum for each table, such that each and every column has to depend upon the primary key column for its uniqueness, no exceptions if you're going to subscribe to the all-powerful third normal form. At any rate, bottom line is, take-home message, you're not going to run out of columns. Chances are very, very dismal indeed, and frankly, if you're running up into 1,000 or more columns in a table, you've got some design problems in my humble opinion. Now, this second bullet point, on the other hand, is of crucial importance for us as MySQL developers. You need to know that architecturally the maximum row size in any database table in MySQL 5 is around 64 kilobytes, or exactly 65,535 bytes. That means a single row can never occupy more than that amount of space on disk. That's just a hard-coded upper limit. Now, how does that affect us as database designers? Well, 2 reasons. 1, it's going to affect the data types that we select for our columns. Actually, even before that, it's going to affect the number of columns we put in our table. Number 2, it's going to affect the data types that we associate with those columns. And number 3, as you see down at the bottom of this whiteboard, you're going to choose a storage engine that's going to map most closely with the properties of the table you're creating. Different storage engines have different requirements. Actually, there's even a 4th point, and that is the character set. So storage engines have disk space requirements. Character sets certainly have disk space requirements, depending upon which one you choose. Some have a wider range of possible characters in their libraries than others. For instance, UTF-8 characters require up to 3 bytes per character. 3 bytes, that's 24 bits. So when you're using char and varchar, especially char columns, you could be running up quite a bit of bytes just with a single column. So the take-home message here is to learn to choose your data types wisely. And you'll remember earlier in this nugget series when we covered data types, I gave you a heads up that some data types occupy more disk space per row than others. You'll also want to keep, as I already said, the number of your columns to the bare minimum in the name of maintaining third normal form. And finally, you'll want to choose the storage engine that makes the most sense given the requirements of your table. And when I say requirements, I'm not just talking about disk storage, disk space requirements, but I'm also talking about performance requirements, because some storage engines in MySQL are faster than others. Let's spend a couple of minutes discussing the SQL syntax behind creating tables in MySQL 5. We've created a couple tables in some previous demos, so you've already seen this command in action. Let's review it formally. Of course, we have create table and then the name of the object. Best practice, keep the name in lowercase, and if you're going to use more than one word in a table, I would recommend strongly you avoid spaces. If you absolutely have to have a space in a table name, you're going to have to put quotes around it to identify the object. Best practice, though, use an underscore character or some similar character to denote the words. There's also what's called camel case. So if we were going to create a table called emp data, for instance, we could use mixed case like this, where the first significant letter of each word is capitalized and the rest of each word is not. It's up to you, though. Now remember, just like when we covered creating databases, we could also throw in create if not exists to do a check to see if a table already exists by the name that we're proposing. This is always, as I said earlier, a good fail-safe mechanism to prevent an accidental overwrite of an object in your database. After we specify the table name, we then open up our column identifiers between parentheses. Actually, all of your columns need to be defined within parens. And I tend to use a lot of white space when I build my tables. That is to say, I will put create table on one row, open paren on the next one, and then a column definition on each line from there. Remember, in the MySQL terminal monitor, you can press enter all day long, and it isn't until you use your statement terminator symbol, the semicolon, and press enter that the entire batch hits the MySQL parser. So if it's easier for you to see what you're doing by using extra space, by all means do so. Similarly to how HTML is handled in a web browser, as long as you have at least one space between your column name and the next piece, which of course is the data type, that's all right. In other words, this could be one space or it could be 100 spaces. It has to be at least one, though. So what you're seeing in the sample table called book is first of all an ID column. This is traditionally going to be your first column that you create for any table. And unless you can think of a column that would be a naturally good candidate for a primary key, traditionally DBAs create a homemade or synthetic column called ID, or in this case book ID, to represent that row level uniqueness. So we have the name of the column, space, and then the data type. This is crucial. We can never gloss over how important it is to choose the correct data type initially. I mean, if you were to start off with, say, a varchar 100, as you see here for the title column, and then a month later, after there's already hundreds and hundreds and hundreds of rows stored in this table, and you do an alter table and change the data type to, say, char 50, you will, without any doubt, see truncation for any rows that go beyond 50 characters. That's not good. That's not the kind of thing that you want to happen. That will definitely spoil your day. Take-home message, choose the correct data type initially at design time. So for book ID, we're choosing small integer. And remember, with numeric data types, you can specify signed or unsigned with that keyword, signed or unsigned. By default, all of your integer data types are signed by default. However, it would make sense that for an ID field, where we're especially going to apply the auto increment property, we would want to specify unsigned so that the numbers proceed from 1, 2, 3, 4, etc. Nullability, the statement null or not null, is going to tell the MySQL engine whether or not that column can contain or has to contain values. If we say not null, then that means any insert of new data on this table will fail unless there is a value provided for the book ID column. Now in this case, we don't have to worry about it because we're throwing in the auto increment property. But for another column like title, we would throw in not null after the varchar 100 and before the comma, by the way, if we wanted to ensure that for every new record put into this table, title was provided, okay? Final thing I want you to see, I'm sorry this is getting kind of ugly with the blue ink, is that you can document your table definitions. You'd use the comment keyword, provide at least one space, and then between double quotes you can put your free text. Commenting and documentation are really, really important database design principles. And if you're creating this table definition in a script file, the comment will be there for all of your fellow developers to see. Will be ignored when you actually run this command in MySQL Server. Never underestimate the importance of column-level comments. All right, anything else interesting here? Titles of varchar 100, authors of varchar 100. Remember, the big difference with the character fields, the character data types, is that chars always reserve that certain number of spaces. So if you had, for instance, char2 for a state field, then regardless of whether there was 2 bytes of data or 0 bytes of data in a particular row, MySQL is going to reserve those 2 characters or those 2 bytes of data regardless. So char can provide more effective indexing and is a good field to use, or as I keep saying field, a good data type to use when you know in advance exactly how many characters a particular field width will be. State is a good example because in this database, for instance, you may want only 2 characters, so char2 would be a good choice here. Zip code might be another one, where you might do a char5 or a char9 depending upon whether you're storing 5-digit or 9-digit zip codes. Our genre column here uses the enum data type, which you'll recall it provides a list from which we can select a pre-populated array. Here we have fiction and nonfiction. And then finally, before we close the parentheses, we're specifying the primary key constraint, and then in separate parentheses, the name of the column to which the primary key constraint is being attached. Now in this example, primary key is coming at the end of the column IDs, but you can actually place the primary key statement anywhere in this entire block between the 2 parentheses. And the reason for that is simple. We provide the name of the column to which the primary key affects right here. Once we close things up with a parentheses, we can use the semicolon and execute the command. Alternatively, we can add some additional parameters like engine if we want to attach a non-default storage engine to this table. So in this example, let's say the MySQL server is using MyISOM for its default storage engine. You can specify engine equals InnoDB and ensure that this book table uses InnoDB rather than MyISOM. Altering tables. Now then, when we use the create table statement, we open things up with parentheses, and then you go ahead and you identify your columns. That's the basic flow. One of the things you need to consider in advance of writing that code is the order in which you want your columns to appear in the base table. Now, in one sense, you think, does it really matter? After all, we don't want our users getting anywhere near to the base tables. We're going to be building views where you can completely customize which columns are pulled from which tables and what those column aliases are and so on. So therefore, what's the big deal? Well, it's nice to have the flexibility here, frankly, because as a database administrator, you're very likely to be mucking around with your base tables. And if you realize that a colleague, of course it wouldn't be you, it would be a colleague, right, inadvertently ordered the columns incorrectly when he or she built a table, you need to understand how to get in there using SQL syntax and reorder those columns correctly. The key to reordering columns, and also while we're on the subject, adding new columns to a table or removing columns from a table, lay in the alter table DDL statement. So let's take these 6 statements, and I'm actually going to add a 7th one to the list that I forgot to add. The first statement says alter table test. We can assume up here that this is the test table, and we have 4 columns, A, B, C, and D. If we wanted to add a new column to the table, and we're just going to not be concerned about where that new column comes in, you can just specify add the new column name, and then your data type, and then any options, and bang. That new column will come by default at the right side of the table. All right, and if that's what you want, that's what you'll get, no problem. Now, what if you wanted the column to appear over here initially? Maybe you had forgotten to add an ID column and you're now creating a synthetic ID column, and traditionally the ID column is shown first in a table. How would you do that? Well, we'd still do alter table, add the new column, data type and all that good stuff, but you'd specify first. As a matter of fact, besides that, you can completely customize the location of the column by using the after keyword. So if we said alter table test, add colX after B, then we know exactly that our new column is going to come in right there. So you now are armed, I think, with exactly the commands you need to add new columns. Now how about changing the data type of an existing column? There what we do is run alter table with the modify keyword and then specify what the changes are. So alter table, here's the column in question, modify, and then you can make any changes. So if colX was set up as a tiny int and you want to change it to int unsigned not null, the modify clause of the alter table statement will get you there with no muss, no fuss, or greasy aftertaste. If we decide that a column is not needed in a table, alter table drop will work just fine. Of course, the caveats there are, number one, you don't get any prompting for confirmation, it just happens. And number two, if this is a live table and you have data in colX, that data will be dropped along with the column definition. If we decide that we want to rename the entire table, you'll find that the rename table statement comes in handy. Rename table test to tested. You'll recall from our previous nugget where we were dealing with creating databases that at one point in time you could use rename database, but MySQL developers shut down that command because of its danger. After all, that's a pretty wide sweeping change. Nevertheless, rename table exists as a valid command and provides a handy-dandy way for you to rename tables. There are still some consequences that you need to be aware of. Consult the reference manual for more information on that. The seventh example that I forgot to put on the slide that I think is really important is simply this. How do we move a column that exists already in the table and move it somewhere else? Like what if we wanted column B here to actually show up after column D? What you would do there is alter table, table name, modify column. So instead of just modify, it's modify column, and then there's the column name. So to recite the syntax, it would be alter table test, modify column colX. Let's just say that B is colX. And then you'd specify either after, before, or first, and then the column name to put after, before, or in the case of first, that's referring to position 1. Therefore, we would say modify column B, and then the data type, after D. On the subject of dropping tables, the purpose of this whiteboard is to show you the distinction between the drop table and the truncate table DDL commands. It's important you understand that difference because it's pretty significant. Drop table removes the table definition as well as the data. And notice that you can drop more than one table at once by just separating those table names with commas. Drop table if exists. Remember, if exists checks to make sure that those tables do exist in the database and suppresses an error message if they are found. Drop table if exists test1, test2 will, without any further confirmation, nuke out those entire tables. And we're talking, they're ripped out right from the roots. We saw this in the last nugget. You can go out into your data directory and you'll see those form files and MYI and so on. Those data files are gone from the file system, and all references to the table are gone from the database. By contrast, truncate table simply empties the rows of the table but leaves the existing schema intact. So truncate table test would ensure that the skeleton, the column definitions, and the data files and index files and so on still exist for the table, but certainly any row data that was there would be gone. This is a nice command to use if you're working in an experimental environment, a development environment, or testing environment, and you want to save yourself some disk space or just reset a table to its initial pristine state. Finally, there's the DML, the data manipulation language command delete, that's used to make subtractions from tables. We could, for instance, remove all employees from a table called emp status where a certain column had a certain value. Actually, I misspoke. The table here is HR and the column or field name is emp status. So this statement, delete from HR where emp status equals terminated, is going to essentially, to put it in layperson's terms, remove every record in that database or in that table, HR table, for a terminated employee. In our demonstration, we're going to build a fresh database and populate that database with one or more tables. I'll show you some various tips and tricks on altering table properties, altering columns, and then ultimately dropping the table when we're finished with it. This should be a very fruitful exercise indeed. In this demonstration, we're going to work with tables in MySQL, creating them, altering them, and dropping them. We're on Ubuntu Nugget here, and to get started, we'll open up a shell prompt, and we'll log into MySQL using the MySQL client. Once here, let's run show databases, just to see what we're working with. We've just got our standard information schema and MySQL databases, two examples, Sequela and World, and a database named, appropriately enough, database that I created earlier. In this example, we're going to use a fresh database. So let's use create database. Actually, you know what I'm going to start? I'm going to at least try to start to be more consistent with MySQL and use keywords in uppercase. So let's say create database corp. There you go. And here's a neat tip. If you're ever in a situation, let me run another show databases, where you're going to create a new database or a new table for that matter, and you want to know the SQL that went into the creation of an existing database, you can say show create database and then specify the name of that database. And what will happen is the response to show create database gives you the exact SQL syntax that went into the creation of that object. Here, all I did was submit create database corp, and the database was assigned to the default character set Latin 1. I'm going to show you a variant of this command, the show create table command, that does the very same thing. Provides a nice way for you to see the underlying structure. This can help guide you in your design of new objects in the database. All right, so let's use our new database, corp, and if I say or type show tables, I'm not going to see anything, of course, because we haven't built any tables yet. Let's suppose, for the sake of example, that in this corp sample database, we want to track all of the staff members of our organization. Therefore, we're going to build a table called staff that has, I don't know, we could put in 5 to 7 columns, just in this simple example, to track things like first name, last name, hire date, salary, date of birth, email. And in doing so, this will give us some practice not only with the create table statement, but it'll also help us in terms of learning to choose the correct data type when we create the object. So let's start this off by saying create table if not exists. Remember how important the if not exists is as a general best practice, and we'll call this table staff. We'll open up the column definitions with an open parentheses, and then we can start in with our columns. Traditionally, I, and perhaps you as well, define ID columns first, and I'll just name this one very simply ID, and I'll use the integer data type. Now if I want to, I can provide a length, but I'm not going to. I am definitely going to specify auto_increment so that MySQL is responsible for increasing the number from 1, 2, 3, etc., and I don't have to worry about it. I can also use, and I will, the primary key statement passing in the column name to denote this constraint and attach it to the column. Now technically you can put your primary key statement anywhere between the outside parentheses. However, it's always made sense for me to attach the primary key statement on the same line where I'm defining that particular column. Comma, and then let's go to our next column. Let's try first name. What do you think would be a good data type for that? Char or varchar? Well, dollars to donuts, you're going to want to do varchar. And the reason for that is primarily disk access and disk storage. And let's choose an appropriate length. I think 20 would work okay for that. Comma. Let's throw in last name. Again, we'll use varchar. 20 is fine. How about date of birth? DOB. What data type would be appropriate there? Of course, date. As a matter of fact, hire date would also be a good candidate for the date data type. How about salary? You'll remember when we discussed data types earlier in the course, I mentioned that when we were dealing with currency, the best data type to use there is decimal. And as far as precision and scale, it depends on how much dough some of the folks in your organization earn. Is it 6 characters? Is it 8? Is it 10? I'm going to go 10 digits out and we'll preserve 2 decimal places. Finally, let's use a timestamp column and we'll call this last updated. And what this will do is use the timestamp data type such that we can always tell at a glance when the last time a row has been modified because, well, we would modify the timestamp data type or the value for this particular row. Let's close things up with parentheses, and if we want to, we can throw in an engine statement to choose a non-default storage engine for this table. And I will. Instead of using the default MyISOM, I'll use InnoDB. Query OK, therefore I can show tables again, and we now have our staff table ready for action. The next thing we'll do is insert a row's worth of data into our new corp table. And to do that, we need the DML statement insert. We're going to say insert into staff, the values, and then here's where things get interesting. We want to make sure that when we do an insert statement, we're addressing every column in the table. So in this case, we have 1, 2, 3, 4, 5, 6, 7 columns. So between the parentheses, we're going to want to address each one of those. And the first question that could be a stumbling block is, how do we address the ID column if it's set to auto increment? Well, what you want to do there, friends, is use the default keyword. What this does is simply says to MySQL, insert whatever default value you have assigned, or if there is none, and as long as nulls are allowed in that column, there will be null or nothing put into that particular row. So much for ID. The values need to be separated by a comma, and any string values need to be enclosed in single quotations. So the first name is going to be Tim, let's say, comma. Last name will be my last name. Date of birth. Now here you're going to want to make sure, and we're going to use single ticks for this even though it's not a string, that we're using the ANSI ISO date format such that 1970-0101 denotes January 1st, 1970. That's not my actual birth date, by the way. Hire date, it's going to be the same thing between single ticks. We'll say 2009-02-01, comma, you can't forget your commas. I'm using the left arrow key to navigate back and forth through this text. Salary, why don't we say 100,000? And then there's a last updated value. But for now, I'm going to close this out, hit a semicolon, and let's see what happens. We get an error that says column count doesn't match value count at row 1. Thing here is 1, 2, 3, 4, 5, 6, 7 columns in the table. Our insert statement is only addressing 1, 2, 3, 4, 5, only some of those items. You see what I mean? Therefore, we're going to have to retry the insert statement. This time, I used up arrow, by the way, to take me back. This time putting in something for last updated. And I can throw in default whenever you're not sure or you just want to throw the onus of that data piece or that data element to the MySQL engine and have it substitute any default value that it can. And as long as we haven't specified not null for the last updated column, saying default here and not putting any data in would result in null for that column. So let's close things out with parentheses and see what happens. It says that our column count still doesn't match. So I'm going to up arrow, and we're going to need to be really careful here and count exactly what's going on. First column is ID. We said default. Then we have first name is Tim. Somehow my last name got lost in the shuffle here, didn't it? So I'm going to have to throw in Warner, single tick, comma. All right, date of birth 1970-0101, hire date 2009-0201. Salary, looks like my salary's gone down a little bit to $10,000. Let me throw in an extra 0. And then last updated, default. So as you see here, inserts can be kind of tricky when they're done manually like this. So it took that time. So let's run a select splat from staff and verify. Sure enough, we've got ID 1, first name Tim, last name Warner, and then so on, going through there. Pretty ugly output, if I do say so myself, but at least the point is made. By the way, I mentioned before, if we want to see the structure of the table, there's actually a couple things we could do here. We could say describe staff, and that'll give us a run of all of the fields, all of the data types, the nullabilities, if there's a primary key, if there's a default value thrown in, and so on. And it looks like for our timestamp column, the default value is going to be the current timestamp. That's pretty interesting. So there's not going to be null put there by default, but actually a current timestamp. In fact, there it is. You can see it's being cut off in my terminal monitor window, but you see last update is showing today's date, because I am in July 2009 actually. The other thing we could do is show create table staff, and this is a little bit different. It gives you what appears to be gobbledygook, but this piece here is of crucial importance because as you see here, it gives us the exact SQL syntax that went into the creation of the table. Now, those of you who have experience with Microsoft SQL Server are familiar with the script as command, such that you can right-click a table and script out the T-SQL that went into the creation of that table. Here you just have to work a little bit differently. You'll use show create table and then the name of the table to get the definition. Works just as well though. There are several ways you can capture this, by the way. I mean, we could definitely copy it right out of this window and paste this if we needed to throw this text into a script file we were creating. Another thing you could do is use the escape character \T with the name of an out file. I'll call this staff table. And as you can see, if you specify \T without the name of a file, MySQL barks at you. And so what this does is turns on logging such that anything I type will be echoed to the out file that I created. So I would simply run show create table staff again, quit out of MySQL, let's do a directory listing, and in whatever working directory you were in at that time, you'll get a copy of that out file. In fact, there it is right there, staff table. So I can open this up in gedit, for instance. You could open it up in WordPad or Notepad if you were on Windows. And sure enough, it's almost as if you took a screen capture of what was on your screen. Anyway, just a couple different ways for you to get hold of data and get it out of that dadgum terminal prompt window. Let's clear our screen, log back into MySQL, and continue. Now, if we show our databases and use corp, show our tables, and we have just the one, let's say that for some reason we were building a new table and we wanted to copy the structure of an existing table. In other words, we really liked what one of our colleagues did with this table staff, and we now want to use it to create another table that uses the same structure. This is a really cool command. You could say create table, if not exists, just as you would expect, and I'll just call this staff copy, like staff. So what you're doing here is duplicating the table in one statement. And by the way, you can definitely do this between databases. So I could say create table if not exists, the name of the database dot the name of the table, like the name of the database here dot staff. So if I wanted to take the schema of the staff table and put it in the world database, I could just specify world.staff copy and corp.staff. In fact, why don't I try that right now? Okay, so we should be able to use world now and show tables and see, sure enough, we've got staff copy. And if we do a show create table staff copy 2, sure enough, the text, the underlying definitional SQL is exactly the same. Now the next question I'm sure you have is, what about the data? How can we get the data from the corp database, show tables from corp, how can we get the data in the staff database table from the corp? Because remember, there is one record in there. Let me use corp, getting a name resolution error here. And if I select everything from staff now, I can see my row. So to take that data out of my staff table here in the corp database and put it into my staff copy 2 database in world, all we would have to do is say insert, let me use my uppercase, insert into staff copy 2. Actually, let's qualify this fully. World.staff copy 2. That's our destination or target table. And we'll say, and this is kind of cool, we're going to be dealing with this in detail in a future nugget. So again, it's one of those cases, friends, where I'm just trying to stretch your horizons, broaden your borders as we're going along here. When you're inserting, you don't necessarily have to always do a value statement and statically plug and chug. You can actually nest a select statement. And in this case, I'm going to say select star from corp.staff. You see how that works? So we're going to take all the rows from corp.staff, of which we know there's just one, and we're going to slam dunk that into our copy, our shell copy database over in world. So it tells us the query was okay, one row was affected, 0 duplicates. So therefore, we can do a select star from world.staff copy 2, and we see the same data. All right. Another neat trick is if, for instance, you want to, like I do, I'm desperate to clear the screen, you can stay in MySQL and execute a shell command by using the \! escape character. So for instance, \! space clear is going to just temporarily duck out of my MySQL session and come back into the bash shell here that's used by Ubuntu. We'll run the clear statement to clear the screen, and then you'll find that we're back in business at the MySQL prompt. That's kind of cool. Let's work with renaming and dropping tables, and then we'll finish with the consideration of changing the row order, changing the column order in a table. And as you see, to follow my code, I've shown my databases, I'm using the corp database, and I've shown my tables. Let's start with drop, very easily enough. Drop table staff copy. We certainly don't need all these duplicate tables. This is an invasion of the table snatchers after all. Query OK. Therefore, we can come back to show tables and we have just staff. Now, what if we wanted to change staff to employees instead? A little bit more reasonable of a name. You remember we have the rename table command, and we're going to go from staff to employees. And I missed a keyword here. It's rename table staff to the new name. Easy peasy. So to change the row order around, it would be helpful to know what order they're currently in. So let's again run a describe, this time on employees. And we see we've got ID, first name, last name, date of birth, hire date, etc. And let's just say for grins that we want salary and hire date to be switched. So how can we take hire date and move it after salary? If you remember our whiteboard, we use the alter table statement. Employees is the name of the table. And if we want to add a new column, let's say we want to put in a middle name column that appears between first name and last name. We would again use alter table, employees, add middle, I'll say mid underscore name. This will be varchar 20 again, after first name. Looking pretty good. Alter table, add, mid name. Looking very good, I think. Therefore, we'll finish with a flourish by describing the table one more time, and you see that we have our new column and our transposed columns. Managing tables and indexes review. In this nugget, we got to know tables to a much more intimate degree than we have so far. I hope you're much more comfortable now as far as the basic schema or properties of tables in MySQL, as well as I hope you're comfortable with the relevant SQL commands for creating tables, altering tables, and dropping tables. Because tables form, as I've said earlier, the fundamental data store of any relational database, it's key that you be really sharp with the theory and practice behind tables. I hope that this has been informative for you, and I'd like to thank you for viewing.